Oh, gravity, you heartless so-and-so. Well, that's what I think when I trip over a stone and fall face down. Of course, I'm not clumsy, you know. Anyway, gravity is a constant, right? Something entirely unshakable that we can always rely on in this ever-changing world. Unlike, love. Feeling romantic, sorry. But what if I told you that it's not as honest and clear as you think? There are places on our planet where gravity behaves like it's gone crazy. And that's why you clicked here. So let's take a look. Magnetic Hill in Leh, India. There's a stretch of road in India that's been attracting tourists from all over the world. It's no different looking from the surrounding landscape, and you could easily pass it by without noticing, if not for one very unusual and a bit creepy thing. If you stop your car on the magnetic hill going up the slope and put it on neutral, it'll start crawling upwards, eventually reaching the speed of up to 12 miles per hour. They say there's some sort of magnetic force at work here that tugs cars up the hill, hence the name. On top of that, even airplanes are said to gain altitude above this place. Skeptics offer another explanation, though. It's just the lay of the land that creates an illusion of going upwards, while in fact you're moving down the hill and vice versa. Whatever the truth, I'd like to see it for myself. Would you? Tell me down in the comments. The Crooked Forest, Poland. Near the village of Nowa Charnowo, there's a forest in the depth of which you can find a strangely looking pine tree. Planted in the 1930s, there are 400 trees that sharply twist to the north almost at the roots, and then grow upwards in a semicircle. Although scientists offer different theories about the tree's weird growth, nobody can say for sure what made them look like that. Some say it's people who did it, while others believe it's a gravitational anomaly that somehow pushed the trees down. The trouble with this version, though, is that it would have had to stay there for years, and that only affected the trees. Still, no certain explanation exists anyways, so who knows? A waterfall, Faroe Islands. Ever seen an upward-moving waterfall? You can have a look at one on the Faroe Islands, halfway from Iceland to Scotland. But if you were expecting me to tell you an unbelievable story about a mysterious force pushing the water up the rock, then sorry, no such thing here. The truth, however, is quite jaw-dropping anyway. The winds in this place are so powerful that they lift the water and throw it back up. I guess it was this kind of wind that allowed Mary Poppins to travel on her umbrella. Sounds good. In fact, this waterfall is not unique. There are several more places on Earth where winds create an illusion of defied gravity. For example, there's the Kinder River in England that has a waterfall constantly struggling with the wind. It's so strong that half of the Cascades water seems to just fly up without ever touching the bottom of the drop. Hoover Dam in Nevada, USA. If you ever get up to the top of the dam, which is about 726 feet high, you can try a little trick. Take a bottle of water and pour it over the edge. You'll see the water flow up instead of spilling down. Once again, this isn't really any magic or unnatural phenomenon. The wind up here is simply too strong for the water to fall, just like with the waterfall on the Faroe Islands. Here though, it looks even more impressive since you can do it yourself. Dokkaebi Road, South Korea. Another gravitational anomaly located on a road. Locals once found out that if you put an empty can or a bottle on the ground, it will immediately start rolling uphill. Unlike other such places in the world though, Dokkaebi Road doesn't just create an illusion. When you walk down the slope, you don't feel as if you're going up. Everything's pretty normal. But once you put down an object that can roll, it will do that in the opposite direction than it should. Local authorities were quick to get the idea and put a signpost directing curious tourists to the mysterious road. Golden Rock, Burma. If you happen to be in Burma, these days it's also called Myanmar, make sure to visit this well-known site. A gold leaf-covered boulder sits upon the edge of a cliff, and a small pagoda is built on top of it. The impressive thing about the rock is that it only lightly touches the cliff for support. In fact, it looks like the boulder will fall any minute now. but it has been standing like that for centuries. On top of that, the pagoda built upon it is not really a recent addition, so it's quite an unusual sight to see. The rock seems to be saying, "Gravity? I don't care about that stuff." The legend has it that what keeps the boulder in place is a single strand of Buddha's hair. Well, I don't know about that, but you can check out the rock for yourself and see that it's not attached to the cliff by anything. And yet, it's not budged for 2,500 years. Something must be at work here, huh? Stone of Davasco, Argentina. If there ever was a thing that said, "I defy gravity" out loud, it's the Stone of Davasco. The huge 300-ton boulder stands precariously on the edge of a cliff and rocks a little bit from side to side in the wind. People even checked it by putting glass bottles under one of its edges. They exploded with another movement of the rock. Unfortunately, today you can't see this wonder of nature as it was a century ago. In 1912, the boulder suddenly dropped from its perch, which it had occupied for literally hundreds of years. The people in the nearby town of Tidally were so sad about this event that 95 years later, in 2007, they decided to restore the stone. Well, not exactly put it together chip by chip. They made a plastic replica of the rock and put it on the same spot and even in the same position. So even today, coming by Tidally, you can see its famous balancing boulder. More of a symbol now, of course, because it's no longer rocking and only weighs 9 tons, but instantly recognizable nonetheless. Devil's Tower in Wyoming, USA. Remember this place from the movie Close Encounters of the Third Kind? If not, you should go watch it, but not right now. This place doesn't make you feel like you're witnessing some magic and doesn't really trick gravity right before your eyes. Sounds almost boring compared with the rest of the sites on my list, right? But the true mind-blowing feature of Devil's Tower is that scientists can't explain how it came to existence in the first place. You see, it's an 867-foot rock formation with walls so steep they're basically vertical. But that isn't even the main thing. This piece of stone just rose amid rolling plains of Wyoming with nothing like it for miles and miles around. So how is it that such a flat landscape could have suddenly given birth to something so tall? Theories abound, but nobody has the answer yet. My theory? Well, perhaps here is where the Earth has a giant Audi belly button. Well then, you come up with a better theory. Oregon Vortex, USA. The House of Mystery in Gold Hill, Oregon amazes its visitors with gravity-defying effects. You can't stand straight there, always leaning to the side and having to hold on to something for balance. Balls roll upwards. And there's also a broom that stands perfectly still wherever you put it, unlike virtually everything else in this shack. The local Native American tribes called this place the Forbidden Ground, even before the house was built there, and they avoided approaching it. The owners of the shack, though, decided to turn it into an attraction, and they succeeded. They created an atmosphere of mystery around the place and spread the news about it in newspapers and later on the internet, and voila, a perfect anomaly is made. In fact, it's no more than a curiosity, a human-made optical illusion that tricks your eyes and other senses. Hudson Bay, Canada. Okay, we've talked about some pretty ambiguous stuff, but now it's time for the real deal, the Hudson Bay anomaly. This is probably the only place in the world where gravity is indeed lower than anywhere else on the planet. Even skeptics can't smirk at it because the difference has been measured with precision equipment. So, does it mean that the gravity here is as low as, say, on the moon then? Unfortunately, or is it luckily, I'm not sure yet, the difference is minuscule. The exact value is 0.005%, or 1/200%. You won't be able to feel it even if you try your hardest, but it's still there. Scientists say this anomaly exists because of the ice sheet that covered the area about 10,000 years ago. It compressed the rocks so much that they still can't fully recover, shifting the gravitational field in Hudson Bay. Sometime in the future, though, the gravity will return to normal in this area as well. No moonwalk for me then.
I'm about to introduce you to a place where the laws of physics take a vacation. Welcome to the mystery spot, where you can witness all kinds of implausible things that will leave you scratching your head in disbelief. Don't worry, it's not sorcery or witchcraft. It's just some clever optical illusions that mess with your brain and make you question reality. Back in the day, when the Great Depression was hitting hard, people needed some fun distractions. That's how the entertainment industry gave birth to the concept of mystery spots. One of the most famous mystery spots is the one near Santa Cruz, California. The name is all intrigue and mystique, isn't it? Once you step inside, you'll see people standing upright on a slanted floor or at impossible angles on a flat surface. You'll see a ball rolling up a ramp defying gravity and logic. It's like being in a funhouse but without creepy clowns. The site is known for its gravity-defying demonstrations, which appear to bend the laws of physics, both on the short uphill walk and inside the wooden building on the site. Misperceptions of the height and orientation of objects occur here. These visual illusions include balls rolling uphill and people leaning farther than normally possible without falling down. Psychologists at Berkeley state that all of the misperceptions stem from the simple fact that the house is slanted at a 20-degree angle. The next stop is again in the USA, but this time at Hoover Dam in Nevada. Here, gravity seems to play with us too. Try this experiment if you ever happen to go there. Pour water from a bottle over the dam. You will witness that instead of going down, the water will start flowing upward. The reason behind this is a very powerful updraft that the structure of the dam creates. In other words, the water gets carried upward by the wind. This trick is not unique to the dam, as there's a reverse waterfall in the Faroe Islands. It occurs due to a wild weather phenomenon known as an inverted waterfall. Imagine a gigantic whirlwind of ocean spray swirling up a steep, 1,542-foot high rocky cliff. So how does this crazy phenomenon happen, you ask? Well, it's all thanks to a spiral column of air that rotates near high and steep cliffs, creating a mini tornado effect. And when the wind hits the edge of the cliff, it gets even stronger and picks up coastal water, which then splashes up the cliff and creates a massive water and wind funnel. Apparently, these inverted waterfalls can happen in other places too, like on the cliffs of Moher in Ireland, the mountains of Iceland, and even in the Waipuhia Falls of Hawaii. Talk about Mother Nature showing off her skills. Magnetic Hill in Ladakh, India? The ultimate mind-bending road trip destination? Here, you can watch objects and cars roll uphill like they're stuck in some kind of magnetic vortex. It's an optical illusion that occurs thanks to the sneaky slopes and general layout of the area. The road might look like it's going uphill, but it's actually a downhill road in disguise, playing tricks on your brain like a mischievous magician. You might also see your car moving by itself in the neutral gear. No, your car isn't haunted, it's just basic physics at work. Even when the engine is off, the wheels can still turn, thanks to momentum and the subtle slope of the road. Mount Aragot has a similar story to the Magnetic Hill of India. This one, too, is like a magnet for thrill-seekers and car enthusiasts. It's located on the border between Turkey and Armenia. It has a reputation for making cars defy gravity. People from all over the world visit this mountain to witness the incredible spectacle, where a car parked on the slope seems to roll uphill all by itself without any driver behind the wheel. There's a nearby river that flows uphill, too. People who visited this site claim that it's easier to go up than down there. Number 6 on the list is the Golden Boulder from Myanmar. The rock looks like it's about to tumble down the hill at any moment. But it's not going anywhere. It's been sitting there for over 2,500 years. The rock is the centerpiece of a stunning pagoda that sits on top of it, towering 49 feet above the ground. According to legend, the rock is held in place by none other than a strand of Buddha's hair. It's no wonder that this place is one of the most important Buddhist pilgrimage sites in Myanmar. The rock was chosen by a celestial king who was impressed by a Buddhist monk's incredible asceticism. So, he used his supernatural powers to carefully place the rock in its current spot, where it looked like the monk's head. If that's not enough, it's said that only a woman can move the boulder. That's why women aren't allowed to touch it. So, if you're up for an adventure, head over to this magnificent rock and pagoda and witness this gravity-defying feat for yourself. Back to the US. Oregon Vortex is located on Sardine Creek, Oregon. It's a tourist attraction that's been around since 1930. The owners of the attraction claim that it's some paranormal activity. But it's pretty obvious some clever optical illusions are involved. Legend has it that even before the attraction was built, Native Americans in the area warned that this land was forbidden, and horses refused to go there. But then, some gold miners built an assay office there in 1904, and the building ended up sliding to a wonky angle. Now picture this. You're in a cozy spot, away from city light pollution, staring up at billions of stars putting on a sparkling show above you. But if you're lucky enough to be in Marfa, Texas, you'll get a little something extra. Mysterious orbs decide to join in on the fun, shining bright like a diamond, and they've been doing it for over 100 years. But what are these glowing orbs called Marfa lights? Well, everyone has their own theories. Some people think they're just car lights from the nearby highway, but that's no fun. Others believe that these orbs are actually sentient beings trying to convey some sort of important message to us, mere mortals. Imagine standing at the edge of a stunning lake, admiring the picturesque view of a majestic volcano. Suddenly, you hear a loud boom and flames shoot up into the air like a fireworks show gone wild. But don't worry, it's not an eruption, it's just the Kauai'an Lake and volcano doing its thing. This fiery spectacle is caused by a natural phenomenon where sulfuric gases burst through the rocks and ignite upon contact with the outside air. The result? Flames that soar up to 16 feet in height, burning blue like the coolest neon lights you've ever seen. And if that's not enough, the liquid sulfur that streams down the mountain looks like a molten river of electric blue lava. It's equal parts terrifying and breathtaking, and a sight you won't soon forget. Speaking of unforgettable things, the Richat structure in Mauritania has been an eye-catching enigma for astronauts since the dawn of the NASA space program. This circular feature in Earth's crust was created by a raised dome that was eroded over time, revealing the original flat rock layers. As you move from the center of the structure outward, you travel back in time, as the older rock layers are exposed in the middle. This geological phenomenon is made up of sedimentary and igneous rocks and measures 28 miles across. From space, you can see several faults where the rock layers have shifted and have been pulled apart. The Richat structure is situated in the heart of the Sahara Desert. There you go. This is our version of the top 10. Would you add something else to this list?
You decide to go out for a morning jog for the first time in your life. You put on your headphones and get ready for something hard and unpleasant. But as soon as you go outside, you feel an extraordinary lightness. At first, you enjoy it and speed up, but then you realize that something's wrong. You're running too fast and too easily. You feel like you've just taken off a heavy backpack that you've been carrying all your life. You're so fast, you think you must have a superpower now. But you notice another athlete running as quickly as you. You notice a puddle ahead of you and jump over it. You jump so far and so high, it feels physically impossible. You fall to the ground, shocked. Then you notice there are no scratches on your body, and the ground feels lighter. You stop the music in your headphones and turn on the radio. All the news reports say the gravity on the entire planet has decreased by half. Thanks to gravity, we stand on the ground and don't fly away into the sky. This power allows our planet to revolve around the sun and the moon to revolve around us. Heavy things seem heavy because of gravity. And now, something has happened to the Earth's core, and the mass of our planet has decreased. This is the reason for the change in gravity. People happily run out of their houses and jump twice as high and further than they used to. Any objects seem twice as light to you. Your body has become lighter, so you can easily stand on your hands. But still, you don't feel like a superhero. You can't lift a car, even if its weight was reduced by half. But now, parkour is easier for everyone than before. Your body's weight has decreased, which means you get less damage when you fall. However, panic quickly replaces the joy of the new conditions. It becomes hard for you to breathe, the same as all other people. The air has become lighter. The updated force of gravity has reduced the air pressure by half. Now you feel like you're at an altitude of 16,500 feet among the streets of a usual town. It's like you're halfway to the top of Mount Everest. The air is no longer as dense, and the main part of it has settled in the atmosphere. In the beginning, everyone experiences massive dizziness and panic. You feel like there's not enough air in your lungs, so you get nervous. To solve this problem, you have to learn to breathe slowly and evenly. Thanks to this, you calm down a bit. Others also learn to be more balanced and don't live in a hurry anymore. All of you experience less stress and enjoy every day. Then scientists create unique oxygen masks. You put it on, take a breath, and a special filter puts pressure on the oxygen molecules, making the air denser. After a couple of decades, people will take off these masks, as they'll ultimately get used to the new conditions. New generations will be born with adapted lungs. The Earth's atmosphere is expanding. It seems the sky has risen higher and acquired a darkish hue. Satellites flying around the Earth's orbit are now inside our atmosphere, but the Earth's gravity still attracts them. You see thousands of satellites burning up. Some of the space debris survives the atmospheric shield and falls to the ground. A meteor shower begins. Space trash crashes into houses, roads, trees, and cars. You and the rest of the people decide to wait out the storm underground, in the subway or basements. Fortunately, the shower doesn't last long. People come out of their hiding and look at the sky in surprise. The moon changes its previous position and slowly flies away. Soon it disappears completely. Our planet is now like a heavy ball in the center of a huge blanket. That blanket is gravity. It bends under the ball's weight. If you put any light object on the blanket, it will roll down to Earth. But if an object is moving at high speed, it will be able to spin on the blanket's edge and not fall into the center. Thanks to such speed, the moon doesn't fall on us, but at the same time, it can't fly away. Now that gravity has decreased, the blanket has become twice as loose. The rotation speed allows the moon to fly out of our gravitational field. It just goes into space. People will be able to observe the wandering moon for a long time through telescopes. Meteorites might crash into it. It could also find another planet with stronger gravity and will revolve around this new home. The moon may stay in place, but will be revolving around the Earth at a slower speed. In any case, there will be no more tides on our planet, and the sea level will remain the same. In the sea, you can also feel the changes. It's much easier for you to stay on the water, and you can swim faster. But the coolest thing is running along the shore. The splashes are floating in different directions, so slowly and beautifully. The waves are running on the sand in slow motion too. The weight of cars, planes, and ships has reduced, and so people consume less gas now. You can drive twice as far with a full tank. Fuel transportation is easier, and less energy is spent on flights. Gasoline is becoming cheaper. The decrease in gravity inspires space tourism development. It becomes much easier for people to fly out of the Earth's orbit. Winter has come. You're walking down the street during a snowfall. It seems to you the snowflakes are stuck in the air as they're so slow. You step on the ice and realize that it's almost impossible to walk on such a slippery surface. Your weight has decreased, and the pressure of your feet on the ice is twice as weak. You're sliding and can't stop. You often fall, but you don't feel any harm. When the wind is strong, it's hard to stay on your feet. If you jump, you may even fly away. The grip of wheels on the road deteriorates. A driver can no longer brake abruptly. The wheels don't spin, but the car continues to slide for a while. That's why new speed limits are being introduced all over the world. You can still enjoy extraordinary strength and long jumps, but after a few generations, the human body will evolve and fully adapt to these conditions. People and animals will be born taller and bulkier. Majestic tigers the size of a truck are walking through the city streets. Flamingos the size of a plane are flying in the dark blue sky. But the worst thing is that the size of insects has increased too. A regular cockroach can now grow to be the size of a computer mouse, and tarantulas become twice the size of an adult palm. At the same time, all living beings become lighter in weight. Humans will become elegant and agile creatures. Our bones and muscles will stretch. The structure of the entire human body will change. will become thinner and smoother. Blood in the veins and vessels will flow more slowly, and it will greatly impair the brain's work, but only in the beginning. In the future, the body will expand. The brain will increase, as will the number of neural connections inside. The lungs will become more sensitive and spacious. People will be smarter and wiser. All devices and materials will be developed according to the new conditions. A cup, a pencil, a plate, phones, and other gadgets. Everything will get lighter and more fragile. If an ordinary person gets into such a world, they'll feel like a superhero. You'll be able to punch through lightweight walls and doors and break bricks with your hand. New people won't match your power, but you'll seem too small and clumsy to them.
You might not think about gravity much, but it affects everything we do. It's the reason why things fall down instead of flying up. It keeps us connected to the Earth, so we don't float away into space when we jump. But for physicists, gravity is something more. It's a fascinating puzzle that needs to be solved to understand how the universe works, and they're on a quest to uncover its secrets. So what's so mysterious about it? Let's see. We've learned a lot about gravity from the legendary Isaac Newton. He was the first to invent the law of gravitation. He taught us that any two objects in the universe can't help but be attracted to each other. It's like they have this secret gravitational crush going on. How strong this attraction is depends on two things. How big the objects are, that is their mass, and how close they are to each other. But here's where it gets cool. Gravity isn't just a two-object dance. It's a complex space choreography. Take our solar system, for example. The sun plays the lead role, using its gravitational pull to keep all the planets in their orbits. But each planet also has its own gravitational mojo, tugging at the sun and even its neighboring planets. Then, a few hundred years later, another hero, Albert Einstein, took gravity to a whole new level. He described the theory of general relativity. According to Einstein, gravity isn't just a regular force. In reality, it's curving and warping the fabric of space-time. Think of it as a heavyweight champion sitting on a rubber sheet. The sheet bends and curves under the weight, and the smaller objects nearby can't help but roll towards the heavyweight. Now, even though we can't see space's curves with our own eyes, we can see what happens to objects that get caught in its grasp. Getting pulled by gravity is like being caught in a whirlwind of forces. The caught object starts spiraling downward, just like a coin in those penny slot cyclone machines you find at tourist shops. Or it might move gracefully in circles, like bicycles racing around a velodrome track. Gravity is the primordial force that guides our entire world. Without it, there would be no stars, no galaxies, nothing. But where does it come from? Well, that's the million-dollar question. And we don't have a complete answer just yet. But we do have some guesses. First of all, we know that gravity is more than just a feature of space. It's a force that pulls things together. Surprisingly, it's the weakest force among them all. But let's take a different look at gravity. Something that may surprise you. Instead of being a force that directly pushes or pulls objects from a distance, it's more like a dance. Gravity, as amazing as it is, doesn't perform alone in this dance. It shares the spotlight with other forces, like electromagnetism, for example. Let's imagine two electrons. There are dancers. Now, they don't directly push or pull each other like you might expect. Instead, one electron creates a special kind of field around itself, like an invisible force field. This field sets the stage for the show. The other electron senses this field and starts to twirl and interact with it. It's like they're following some choreography. And when we watch this dance, it looks as if the second electron is being pushed or pulled by the first one. But in reality, it's all about the intricate movements and interplay between the dancers and the field they're dancing in. The dancers never touch each other directly, but their interactions through these fields make it seem like they're connected. It's a magical display of fields and movements coming together to create the illusion of forces at play. The thing we call gravity. So even though it's not a force in the usual way, it behaves like one. We call it an emergent force, because it emerges or comes out from the way space and objects interact. Which is why, if we want to get technical, some scientists prefer to avoid the words gravitational force and opt for the term interaction. It's just a way for particles to mingle and exchange energy and information. Electromagnetic interactions, gravitational interactions, They're all part of this grand soiree. At least that's one of the theories. Some scientists also think that gravity might be made up of tiny particles called gravitons. These sneaky particles work behind the scenes, making objects attract each other. However, we haven't been able to directly see these elusive gravitons yet. So, according to this theory, gravity is both a force and a potential particle. As you can see, we have some struggles with explaining how gravity works on a large scale. But at least we have a good understanding of how it behaves in certain situations, like how planets orbit the sun, or how objects fall to the ground and stuff. But what happens when we zoom into the atomic scale? And what if we venture into the depths of black holes and the Big Bang? Now here's where gravity's wild ride goes off the rails. First, let's enter the realm of quantum mechanics. There's something peculiar that happens in this tiny world. Gravity, the force that pulls things together, seems to take a back seat. On a microscopic scale, other forces like electromagnetism take the spotlight and become the superstars. They're overshadowing gravity, and this leaves scientists scratching their heads, wondering, is this possible? Why does gravity suddenly fade away? So far, we have no idea. And when it comes to the grandest scales, where immense objects like black holes, gravity takes on a whole new level of complexity. For example, inside a black hole, laws of physics and gravity, as we know them, basically fall apart. It also decays when we try to understand how gravity behaved immediately after the Big Bang. Where did it even come from? We have no idea. In other words, we find ourselves in a cosmic fog when it comes to understanding gravity. But fear not, scientists are working hard to learn more about this enigmatic, emergent force. They're doing all sorts of experiments and using fancy technology to crack its code. Even though we still have a lot to figure out, we're making progress every day. For example, have you ever heard of gravitational lensing? It's like a mesmerizing magic trick. Imagine a beam of light as a fearless explorer, taking a straight path through the universe. But as it encounters the gravitational pull of a massive object, the light's journey becomes a wild roller coaster ride. The gravity of the massive object bends the fabric of space-time, creating a funhouse mirror effect. Our brave beam of light finds itself curving and twisting around the massive object, following a new unexpected path. But as the light changes its trajectory, it also reveals to us distant and hidden wonders that would have remained invisible otherwise. The light can magnify, distort, or even create multiple images of faraway objects. So all the things that have been playing hide and seek with us finally become visible, like black holes. There's also a mind-blowing idea called gravitational waves. Einstein predicted their existence tens of years ago, but only recently have we finally been able to confirm them. And that was a huge breakthrough in the science world. These waves carry the echoes of cataclysmic cosmic events, such as the collision of massive black holes or the birth of newborn stars. Just like dropping a pebble into a serene pond, these crazy events cause a ripple effect. But instead of water, it's space-time itself that ripples and warps. Scientists have just recently developed a way to listen to these whispers. They've created instruments capable of detecting these gravitational waves. These instruments, known as interferometers, are like ears that are finely tuned to catch the subtle vibrations of the universe. But one thing's for sure, gravity is a superstar that shapes our universe. It keeps everything around us connected and rules our entire universe. The quest to unveil its ultimate secrets continues, and it's a thrilling adventure for scientists and curious minds alike.
How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the north and south pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans, and you get a geoid. In reality, the line stretches across oceans, as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material, which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. there were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic.
Legend has it that in the 17th century, Sir Isaac Newton noticed an apple fall from a tree and began wondering why the fruit had fallen to the ground and not upward or sideways. Well, that would be freaky. After years of studying, he concluded that gravity must be the culprit. The scientists called it a force of attraction that existed between all objects. But it was Albert Einstein, many years later, that revolutionized these ideas about gravity. Legend also has it that he wasn't completely satisfied with Newton's findings. Something just didn't seem right. As a young scientist, Einstein had some trouble formulating his theories, trying to explain the behavior of moving objects. When an experiment came to his mind, he called it the happiest of thoughts. Gravity feels like the sensation of riding in an ascending elevator. He called it general relativity. Einstein began working tirelessly, trying to prove this idea. At one point, he even complained he was on the brink of losing his mind. Now, in the simplest terms, general relativity claims that gravity is the curvature or warping of space. The greater mass an object has, the more it warps the space around it. Imagine a heavy ball resting on a trampoline. The rubber sheet under it gets warped under its weight. It's the same with our sun. It's big enough to twist space across the entire solar system. That's why our planet, as well as all the others, orbit around the star. This warping also impacts how we measure time. If you look at your watch, time seems to go by at the same rate every day. But if you hike to the top of a mountain and your friend wanders through a valley at the bottom of this mountain, you'll see that your watches will calculate time differently. One watch will tick faster, while the hands of the second one, which is traveling through the valley, will move more slowly. That's because gravity affects how fast time goes by. With these experiments in mind, Einstein concluded that gravity was not a force of attraction, but rather a curvature in the fabric of space-time. We feel gravity as a force simply because we're placed on some surface. If there was no surface and no attraction between us and this surface, we would become weightless. If you don't mind getting some weird looks, try this experiment. You'll need a bathroom scale and an elevator to ride. You'll soon see that your weight fluctuates as you move up and down in the building in the elevator. The gravitational force is the same, but your weight is different because the elevator speeds up and slows down. Aboard the International Space Station, astronauts literally move along with the station, so there's nothing to push them against the side of the station so that they have some weight. Even if we still think of gravity as a force, it's the weakest one we know. First of all, it only attracts. There's no negative counterpart that could push things away. And weirdly, even though this force is strong enough to keep galaxies together, we still overcome it every day. Every time you lift an object off the floor, you overcome the force of gravity produced by the entire Earth. Ooh! Just to paint a better picture, Earth's gravitational pull is weaker than the power of a refrigerator magnet. The fact that our planet has gravity also affects the way we look and act. All creatures on Earth are limited in growth by the height of their skeleton and by how much weight it can carry, which is directly proportional to gravity. That's why some marine creatures can grow bigger. The largest animal on our planet right now is the Antarctic blue whale. It's about the size of 2 school buses combined. That's because sea creatures can float, which slightly counteracts gravity. The effects of gravity can be seen in people, too. We are taller in the morning than we are in the evening. Our everyday activities and the added effect of gravity make the cartilage in our ankles, knees, hips, back, and neck compress. Once you have overnight rest, the cartilage swells back to normal. Gravity might also affect your shower routine. That is, if you're an astronaut. They have to rely on the old-fashioned way of bathing up there on the space station. They can't take a shower since the force of gravity up there is different and water doesn't flow as it should. Instead, they use liquid soap, water, and no-rinse shampoo. They first squeeze some liquid soap and water from pre-made water pouches onto their skin. Next, they open the no-rinse shampoo and add a little water to wash their hair. Towels are then used to wipe off the excess water, which is really precious in space. To make sure they recycle it, an airflow system quickly evaporates excess water. Gravity and weight shouldn't be confused. Astronauts on the space station do float, and you may sometimes hear that they are in the state of zero gravity. It's far from the truth, though, since gravity up there is about 90% of its value on our planet. But astronauts look and feel weightless, since weight is the force a certain object exerts on them back on Earth. Most creatures have evolved to sense and adapt to Earth's gravitational pull. In the sea, for instance, some fish have floating calcium carbonate deposits in their heads. Scientists call them ear stones, and they're pulled down by gravity. They act like a fish's internal compass. Now, plants have evolved to grow starch grains in the tips of their roots. They use this amazing feature to force their roots deep down into the soil. As little as we seem to understand it these days, we do need gravity for way more things than we can imagine. For instance, some bacteria become even more dangerous in space where there's little to no gravity. Salmonella, for example, the type of bacteria that is known to cause food poisoning, becomes 3 times nastier in the condition of microgravity. So you really gotta cook your chicken. Our own moon stays where it is because of the effects of gravity, too. If it weren't for this force, our satellite would have floated away by now. But it's held in place by Earth's gravitational pull. Objects with the biggest gravitational pulls in the universe are black holes. Thankfully, our planet is really far away from any of them. Nothing can escape the gravitational pull of a black hole, not even light itself. Similarly, gravity is different on each planet, and because of that, things weigh differently depending on which planet they're on. Take Earth, for example. An object that weighs 100 pounds here would only be 38 pounds on Mercury. But if you're planning on losing weight fast, try booking a trip to Pluto. Someone who weighs 150 pounds on Earth would weigh no more than 10 pounds on Pluto. The same person would weigh considerably more on Jupiter, which is the planet with the most powerful gravity. 150 pounds on Earth would turn into more than 354 pounds there. No thanks. Remember that experiment with watches ticking at different levels of elevation? It turns out that gravity isn't spread evenly on the surface of Earth. Why? Because our planet isn't a perfect sphere. The mass of Earth isn't evenly distributed either. That's why you get variations in gravity in different locations. More so, gravity is weaker at the equator because of the centrifugal forces produced by the planet's rotation. Since we've always perceived gravity as a force, we seem to believe that it has somewhat of a suction motion. But it's not exactly true. Back in 1998, scientists were baffled to see that the expansion of the universe was speeding up. So they linked this to the repulsive gravity of mysterious dark energy. We now know that dark energy makes up for more than 60% of the mass energy of our whole universe. But since nobody knows what it actually is, we can only make assumptions. And one that's largely accepted is quantum theory, which seems to claim that gravity pushes rather than pulls things in. You got all that? I may need to watch this one again.
"1.5 feet with the Earth's gravity. Verification complete. Now the simulation room will recreate Mercury."
It's so hot in here.
Yes, it's like standing next to a volcano. Your jump is 4 feet high. Now switch to Venus.
Wow, this place looks scary.
On the real Venus, everything is toxic.
I feel no difference.
Yes, the gravity here is almost the same as on Earth. Switch to the Moon. Gravity on the Moon is 10 times lighter than Earth's, 9 feet. The next one is Mars.
Huh? It's pretty comfortable here.
The gravity here is the same as on Mercury. 4 feet. Now, prepare for the struggle.
Huh? What do you...
There is no solid surface on Jupiter. Although Jupiter is a great deal larger in size, its surface gravity is just 2.4 times that of the surface gravity of Earth.
It's hard to even stand here.
Only half a foot. Got it. Switch to Saturn. There is no solid surface here either, but Saturn's gravity is almost the same as Earth's. Now Uranus.
It's so cold.
It's 5 times warmer here than on the real Uranus.
Seriously? My legs are...
1.7 feet. Gravity is slightly weaker than Earth's. That's Neptune for you. Your jumps are 1.3 feet high. Gravity is slightly stronger than Earth's.
Get me out of here!
Turn off.
How do people usually describe planets? Massive, freezing, boiling hot, seismically active. Let's admit it, shiny is not normally on the list. Unless we're talking about a world called LTT 9779b, which might be the shiniest planet we've ever seen. This exoplanet, which is basically any planet outside our solar system, is ultra hot and acts like a giant space mirror because it's covered with a thick layer of reflective metallic clouds. This unusual world is located about 264 light-years away from our planet. And the most amazing thing about it is that it reflects approximately 80% of all the light its parent star sends its way. For comparison, Earth reflects a mere 30% of the light it gets from the Sun. The bizarre exoplanet is even more reflective than the shiniest planet in the solar system, Venus, which reflects around 75% of sunlight due to its thick clouds. LTT 9779b is 5 times as large as Earth, which makes it the largest space mirror ever discovered. By the way, this world was found by NASA's Transiting Exoplanet Survey satellite mission in 2020. But the highly reflective nature of the planet was uncovered later, thanks to a follow-up investigation conducted by the European Space Agency Exoplanet Hunting Spacecraft, CHEOPS, which stands for Characterizing Exoplanet Satellite. Now, imagine a planet the size of our ice giant Neptune. It's a burning world floating close to its star. If you stepped on its surface and looked up, you'd see heavy clouds of metals floating over your head, raining down titanium droplets. The planet's size, coupled with its insane temperatures, allow astronomers to classify the planet as an ultra-hot Neptune. Now, a planet's high reflectivity is a quality known as albedo, and in the case of our shiny world, its albedo mystifies scientists, all because most planets that are not ice worlds or planets with thick layers of reflective clouds like Venus normally have low albedos. Their atmosphere or surfaces simply absorb the light coming from their stars, preventing it from getting reflected back into space. And initially, researchers were sure that LT9779b would have a low albedo. After that, by no means was it an ice world. Not with the surface temperatures reaching 3,650 degrees Fahrenheit on the side of the planet permanently facing its parent star. It was supposed to be too hot for water clouds to form. Even clouds of metal or glass wouldn't be able to form in such a scorching climate. Astronomers expected a planet like that to have its atmosphere destroyed by its star, which would leave behind a lifeless, rocky world. That's why discovering metallic clouds was so unexpected. Of course, researchers were eager to find out how such clouds could have formed. It had remained a mystery until they decided to think about the cloud formation in the same way as condensation that appears in the bathroom after you take a hot shower. There are two ways to steam up your bathroom. You can cool the air until the water vapor condenses, or you can keep hot water running until clouds form. It will happen when the air in the bathroom becomes so saturated with vapor that it won't be able to hold it anymore. So, researchers came to the conclusion that most likely the atmosphere of the shiny planet became oversaturated with silicate at one point. And then, metal started vaporizing due to boiling hot temperatures on the permanent day side of the planet. But if you think that the reflective nature of LT9779b is its only unusual feature, you might want to hear this. The exoplanet is an example of an extremely rare planetary type, and ultra-hot Neptune. Astronomers have been searching for such planets for decades, but those preferred to remain a mystery. The fact that the planet survived so close to its star might be linked to its high reflectivity. Some experts believe that the metal clouds covering the planet probably reflect light and prevent the planet from overheating and evaporating. Plus, such a highly metallic atmosphere is much heavier and harder to blow away than any other. Now, about 850 light-years away from Earth, a planet called WASP 121b orbits its star. This planet is a hot Jupiter, which means it's a gas giant moving very close to its star. And because of such a short distance, the planet is also insanely hot. The average day temperature there is around 5,000 degrees Fahrenheit. Interestingly, just like our previous shiny world, this planet also has metallic clouds floating over its surface. But that's not the only oddity. WASP 121b has a bizarre oblong shape. Can it be because the planet is tidally locked to its star? It means that one of its sides always faces the star, while the other is always turned to the darkness of the cosmos. In other words, it's always daytime on one side of the planet and nighttime on the other, which causes crazy temperature differences. Researchers think it might be the reason for the metallic clouds. The water cycle on WASP 121b is also pretty bizarre to say the least. On the illuminated side, the atoms that make up the planet's water get ripped apart by the insane temperatures. After that, they get blown by winds moving at 11,000 miles per hour to the other side of the planet. There, much lower temperatures allow the atom to recombine into water molecules. At the same time, the nighttime side is cold enough for metal clouds consisting of iron and corundum to form. When these clouds migrate to the daytime side of the planet, they vaporize and rain down metal on the planet's surface. But if these clouds don't seem impressive enough, I've got more. Astronomers predict that the planet will rip itself apart in the next several million years because of its incredibly fast winds and wild temperatures. Plus, the gravitational pull of the planet's parent star also plays its role in this dark prediction. Since WASP 121b is so close to the star's gravity pulls the planet into a weird oblong shape and makes gases like iron and magnesium leak from the planet's atmosphere. This pull is so strong that the planet is always on the verge of a tidal disruption. If it ever happens, the planet will come apart for good, metallic clouds and all. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists got some proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. Another planet you probably shouldn't set foot on is WASP 76b. There, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit larger than Jupiter in terms of size and is located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between the planet and its parent star is 10 times shorter than the distance between Mercury and the Sun.
You wake up, gasping for air, struggling to peel yourself from your bed. When you do manage to get your feet on the ground, it feels like they're glued down tight. You're twice as heavy. It feels like you're carrying another you on your shoulders all day long. Well, congratulations. You've woken up on an Earth where uncontrolled experiments with dark matter have doubled the force of gravity. Mass panic happens when over 8,000 aircraft fall as soon as the gravity spikes, crashing into buildings, forests, and oceans. And that's because airplanes suddenly lost the balance between the pull of gravity and the lift force necessary to keep them cruising. Pilots did attempt to save their planes, but GPS failed as satellites swiftly moved. After a month, humans begin to look more and more like chimps. Bones are getting thicker, and the immense force constantly pulling people down is squashing their spines, making everybody bend over. People start figuring out that walking ape-style on all fours helps with better balance and stability. And that becomes a big deal, since even tripping over a tiny rock could lead to a nasty fracture. Falls not only get more intense due to the extra forces on bones and joints, but they also happen faster. Gravity's pull doubles the acceleration force, increasing it from 32 feet per second to 64 feet per second. Your house is not a safe place anymore. Old buildings and bridges all over the world are now collapsing. Inside those still standing, residents get the scary feeling that the whole place is shaking, and cracks start showing up everywhere. It's dangerous to stay inside houses, as roofs are now twice their usual weight, and any rain or snow also feels twice as heavy. Car alarms are constantly going off because tree branches keep falling all over the place. Most trees simply can't bear the weight of gravity, and only strong and small plants survive, like cactuses and succulents. 6 months after the sudden change, supermarkets have a sinister vibe going on, with shelves nearly empty and people arguing over the last loaf of bread. You get frustrated to see that your favorite Japanese restaurant is now 5 times more expensive. And it's not just about salmon prices. It's rice that has become a rare luxury item, since the gravity boost has messed up the photosynthesis process, and the seeds are taking too long to grow. On the flip side, carrots are now cheaper than ever. They're sprouting and growing at lightning speed. People start eating so many carrots that human skin now has an orange glow from all that extra beta-carotene. Farmers are getting creative, using artificial supports to keep plants like tomatoes and corn on their feet. But even with all their efforts, it's hard to get a good harvest. Summer has arrived, and even your air conditioner can't relieve the unbearable heat. A sudden change in gravity disrupted Earth's orbit around the Sun, pushing it into a new, tighter elliptical path. Earth now passes much closer to the Sun than it used to, making your sunscreen simply surrender. The Moon's orbit has also had some dramatic changes, leading to more dangerous and extreme tide patterns. High tides are now higher and low tides are lower. This shift has also triggered widespread volcanic eruptions and earthquakes on an unprecedented scale. Earth's crust starts to rupture across vast areas, unleashing planet-wide lava flows so intense that living on Venus begins to sound like a pretty good idea. 5 years later, people notice that puppies are begging for food twice as much, but they are taking more time to grow. Breeds like beagles look thinner and their leg bones are getting heavier. Even insects, such as locusts, now have thicker hind legs to keep those jumps going. Sea creatures are being crushed by the much greater weight of the water around them. That's not a big deal for animals used to deep ocean pressures, like the anglerfish, but crabs and lobsters are really struggling since they live in shallow waters. Sloths and monkeys develop a stronger grip so they won't fall off trees. For carnivorous animals living in jungles or savannas, life is a real challenge because any animal the size of a wolf or bigger can't run without breaking a leg. Large predators like lionesses are starving because they can't move fast enough to catch their prey. Tall trees like palms and pines also go through evolutionary changes. They get beefier trunks and only grow about half as tall as usual. This way, water and nutrients can travel from the ground up to their leaves without struggling against gravity so badly. 10 years have passed since gravity increased. Airlines have finally made changes to prevent commercial flights from nosediving. The wings of airplanes are now longer. Pilots have learned to fly at altitudes twice as high, and flight speed has increased by 41%. To avoid people getting extremely nauseated and dizzy during takeoffs and landings, seats are now fully horizontal, like first-class bed-like setups, specially designed to minimize the nasty effects of gravity times 2. Flight attendants are trained to raise the seat at the passenger's feet after they pass out, so that blood can return to their head. The thing is, when gravity gets a power boost, it yanks your blood down to your feet and hands even more than usual, making your heart work extra hard to pump that blood around, especially to your head. 50 years have passed. Women in their 30s look like they are 60. Higher gravity decreases collagen synthesis, so even though they're still young, they're dealing with more wrinkles and fine lines, and their skin has already lost a big part of its elasticity. Wounds as small as a pimple pop or a paper cut also take much more time to heal. So people are excited about the creation of a Band-Aid made from fish skin from cod or tilapia that promotes local blood circulation and speeds up the healing process. People have also got used to wear exoskeletons made of titanium, which support and enhance the wearer's strength. This technology features cool joints at the places that copy humans' natural movements, giving people more flexibility and letting them move around more easily. Prototypes of personal flying devices start popping up after 100 years. The Gray Flyer is like a jetpack made of carbon nanotubes, making the structure strong without adding much weight. Instead of using fuel for propulsion, the device has these super thin but high-tech solar panels. Investors are still not sure if humans could fly long distances with it, but the Gray Flyer definitely can help people tackle tasks that have become almost impossible, like climbing a mountain or grabbing something from the attic. Things at the gym are pretty different too. The anti-gravity treadmill is a favorite among fitness enthusiasts because it uses air pressure to lift users, reducing the discomfort of gravity while running. People can also lift weights in booths when the gravity settings are customized. When training with G-force set at 3 or 4 times the new normal, muscles get stronger, making double gravity seem more bearable. However, the maximum set is 4.6, otherwise bones might crack. Over 500 years have passed. Thanks to these amazing technological creations, humans can now handle and establish colonies in other parts of the universe. A popular choice for family vacations is Kepler 452b, a planet about 60% larger than Earth, orbiting in the habitable zone of a sun-like star. Kids especially like that place, as oceans have been discovered and hotels have been built near rocky beaches. On the other hand, traveling to places in the universe with lighter gravity is like going to an oasis of tranquility. So Mars and the Moon have become known for amazing yoga retreats. With their gravitational forces much weaker, people can breathe more easily there and move around with more freedom. Keep in mind that these trips are expensive, so you might want to start saving up now.
Imagine a world where instead of water, the oceans are made of methane. Yeah, that's right. Instead of swimming in H2O, you'd be paddling around in CH4. It's like Mother Nature's version of a fizzy drink. Such oceans actually exist on one of Saturn's moons called Titan. In fact, the methane and ethane on Titan play a similar role to the water on Earth. They cycle through the atmosphere and form clouds that eventually rain down onto the surface. They were discovered by the Cassini-Huygens space probe, and apparently, our entire planet's oil reserves could fit in one of Titan's puddles. Even the desert sand dunes on Titan have more organics than all of Earth's coal reserves. Who knew that Titan was the place to go if you're ever in need of fuel for your car? Now, obviously, there are some things that distinguish methane lakes from our water ones. First, the temperature on Titan is around -290 degrees Fahrenheit. It's like taking a dip in a giant glass of liquid nitrogen. Not exactly ideal for a beach day, is it? Methane is also less dense than water, so if you were to go swimming in such an ocean, you'd float like a balloon. On the bright side, it would make doing the backstroke a lot easier. Next, while water waves can be pretty majestic, unfortunately, we can't ride any on Titan. Cassini didn't detect any big waves there. Maybe it's due to low seasonal winds, or the fact that some of the lakes are much smaller than Earth's lakes, but we don't know for sure. Also, I know what you're thinking. If the oceans are made of methane, could you set them on fire? Technically, yes. Methane is a highly flammable gas, so if you were to light a match in a methane ocean, you'd get a pretty impressive but dangerous blaze. So, given all these differences, the question arises, what would a planet with such oceans look like? Well, we can make some guesses by looking at Titan. First of all, its atmosphere, composed primarily of methane, would be incredibly thick. Titan's atmosphere reaches nearly 370 miles into space, and the atmospheric pressure there is 60% greater than Earth's. So, if you ever wanted to experience the feeling of swimming super deep in the ocean, now's your chance. Also, methane is a powerful greenhouse gas that traps the sun's heat really well. That's why our planet would warm up faster than a sauna. You may ask, why is it so cold on Titan then? This is because this moon is very far from the sun, and light doesn't reach it well. But if we place our planet somewhere in the middle, then the temperature may even be quite comfortable. Actually, methane oceans on a planet could really spice up the climate. The planet would be a breeding ground for methane clouds. Just like on Titan, it could form an orange-colored haze, or smog, that would make our planet look like a real mystery. It would be difficult to see us from space without some special telescopes. And let's not forget about methane storms. They would also occasionally drench the surface, so remember to bring your umbrella. But hey, at least the heavy carbon-rich compounds would make for some pretty sweet dune fields. And finally, the most important difference. While water oceans on Earth are teeming with all sorts of creatures, we're not sure if there's any life in methane oceans on Titan. If there is, they'd have to be pretty tough to survive in such extreme conditions. So, if life on such a planet exists, it would be very different from what we're used to seeing on Earth. For example, microbes might be able to handle it. These tiny resilient creatures can survive in a wide range of environments, including extreme ones. So it's possible that microbial life could exist in methane oceans. And what about us and animals? Well, scientist Robert Zubrin thinks that Titan might be the perfect place for humans to colonize in our solar system. According to him, this little moon has everything we need to survive and thrive. And if it's possible on that moon, then it could work with a planet too. For starters, we'd need some oxygen to breathe. We could use nitrogen and methane in the atmosphere to create breathable air and rocket fuel. We could also use these elements to make some fertilizers and grow plants. Next up, we'd need water. Since the oceans are made of methane, we can't exactly drink them. We'd need to find or create sources of water. Scientists believe that it actually may be hidden below the surface on Titan, together with some ammonia. We could use it to drink, or create even more oxygen. So, with all of these resources, we could create a self-sustaining colony even in a place with methane oceans. Piece of cake! Although, there are always alternatives. Maybe we could become methane breathers, evolve into organisms that use methane instead of oxygen. For example, we could get some large lungs because we'd have to inhale a much larger volume of air, since methane is less dense than oxygen. But this is pure sci-fi. Methane oceans are not the only unusual oceans in space. It turns out that seas on diamond planets may be even weirder. Take WASP 12b, for example. This exoplanet, located about 1,200 light-years away, might have oceans of tar. That's right, tar. The planet has more carbon than oxygen, which means its crust is probably made of things like diamond and graphite, instead of your average silica-based minerals like granite. Imagine stepping on this planet, and the first thing you notice is that the beaches are made up of black goo. It's like stepping into a nightmare, where you're trapped in quicksand made of sticky sludge. So forget about the sandy beaches and crystal clear water you're used to. Here, you'll be living the pitch life. Your swimwear will be replaced with hazmat suits, and you'll need a sturdy pair of boots to walk on the sticky surface. But in reality, WASP 12b is not the place to look for geology of any kind. It's simply too hot for anything to survive, let alone thrive. But there might be smaller, similar exoplanets where we could potentially live. Now, you might be thinking, tar oceans? That's crazy talk. But did you know that there's a 246-foot deep lake of natural asphalt here on Earth? It's called Pitch Lake, and it's located in Trinidad. It's formed when oil is forced to the surface, and the lighter components evaporate, leaving the thicker, heavier pitch behind. And guess what? This lake is home to a thriving ecosystem of microbes. So if you want to live on such a planet, at least you won't be alone. You'll have plenty of company in bacteria, fungi that love to feast on carbon found in asphalt, and archaea that live on methane. And finally, there are oceans of molten rock. That's right. Imagine a world where the floor is lava isn't just a game, but a reality. Welcome to 55 Cancri E, a planet so hot that the entire hemisphere facing its star is covered in magma. It's like a scene out of a heavy metal album cover. But don't worry, the other side of the planet is slightly cooler, so you can at least step off the lava and catch your breath. If you're feeling adventurous, you could always hop over to Koro T7b, another super Earth where the lava ocean is just as scorching. But this time, the night side doesn't offer much respite either. It's still seeing constant volcanic eruptions, like some sort of fireworks show. Scientists are scratching their heads trying to explain why these planets are so hot, and why they haven't cooled down yet. Maybe they're just really good at retaining heat, or maybe they just have a bad temperament. Either way, it's probably best to stick to playing the floor is lava on solid ground, and leave the real lava planets to someone else. All this diversity of oceans shows us that the universe is always full of surprises. It never ceases to amaze us with its creativity. Although these oceans are not suitable for human exploration yet, they challenge our understanding of what could exist beyond our world. So, let's continue to explore.